Good afternoon. My name is Peace炁from TNO. Glad you could make it to the session. And today I'll talk about collecting traffic data and have we collected enough. So first of all, let's talk about why this is important and how much we should actually collect. Then about using scenarios to capture the repetitiveness of the driving data. Next, I'll talk about parameterization and comparing data sets and come to a conclusion. So first of all, why is this important? Well, if you want to develop and release a car with automated driving or ADAS, you want it to be ready for the situations on the street. So you need to know what these situations are. For your safety evidence, you need to be able to say, okay, this situation has an exposure, this or that much. So this is how I handle it in my safety case. There's a lot of companies already collecting data, intense data collection campaigns. This raises the question, can't we in some way get more information from this together? It's also a very costly thing. So in these times, your boss might say, aren't you ready yet? The simple answer is no, but then you want some reasons why you need to continue. So how much? You have probably seen these numbers before. If we want to collect data and we want to tell something about the exposure to accidents, we probably need to drive 2.5 million kilometers, and a more recent number even says 700 million kilometers for highway fatalities. So it's years of data collection and it's simply not feasible. So we move to scenarios, and the Head Start EU project addresses this topically in full detail. So it's looking at input from field data, aerial data, other sources and accident data, integrate them into a database, then derive scenarios from that, and using them in simulation, XIL, testing ground and field testing. So the good thing about scenarios is that they actually describe the repetitiveness in traffic. And it does so with different parameters for each observation. But then there is a scenario category that very powerfully describes what's happening on the street. So if we, instead of driving millions of kilometers, we turn to scenarios now, we have 3 challenges. We need to collect enough scenarios, we need to do accurate parameterization, and we need to handle rare cases. So first of all, we want to decide whether we have collected enough scenarios. And do we cover all the driving that we have in our test runs? So to do that, we need to decide what counts and what's in. So the duration of the scenarios that we see. And there it becomes a bit arbitrary because it's not so clear exactly on what second a scenario stops or starts. And there can be various definitions. And also they happen in parallel at a various rate. So sometimes there's 1 or 2 or 3 scenarios happening at the same time. So to deal with that, TNO come up with a metric called time coverage. And essentially it's 1 minus the time not labeled. And in this way we can express it. As an example, you can see that with only 7 scenario categories, you can already cover 80% of highway. So as you see, we quickly move to 80%, and then there is work to do to raise this to a higher level of 100%. So this is a very simple measure to see how we're doing. So we go a level deeper in characterizing whether we have collected enough scenarios. We look at the parameterization. First of all, using engineering know-how or advanced techniques, we look which parameters are important for a certain scenario. Then we estimate the probability density function. So how probable are certain parameter values? And thirdly, we estimate the uncertainty of the probability density function. And this helps us as a measure of the accuracy of the parameterization. And in this way, we get a much better grip on how complete our data collection is. So just as an example, if we add data sets to a parameter distribution, for the first data set it might look like this, for the second and the third together it looks like this, for 3 data sets it looks like this, and for 4 it looks like that. So clearly the distribution is changing, but it's a bit hard to tell the difference. So we came up with a measure for that. And this is a measure that estimates the uncertainty of the probability density function. It uses a kernel density estimation to estimate the real PDF, so where the PDF is heading to. And it compares the current PDF with the estimated real PDF. And AMISE is a measure for the difference. So if we look now at this graph for 4 parameters, we see with each data set the AMISE score goes down, which is what we want. And for most parameters, but here, for example, for this parameter, we see it goes up with the third data set, meaning that there is more information in this new data set. It shows other behavior. So it's important to collect more data to bring this down to the same AMISE level again. The last challenge is to handle rare cases. We all know that if you drive around on the road, it takes a long time to actually observe and measure an accident. And it would also be very costly to be involved in a measurement with your nicely equipped car. So that's not something that can help us a lot. Of course, you can use theoretical approaches like extreme value theory. They use a lot of assumptions, and for multi-parameter spaces, they are limited. So let's not assume that path. In the ISO SOTIF working group, the approach is different. Let's more looking at the causality of what is happening and decomposing hazards into their contributing causes in the triggers. And for each of these triggers, you may have data and you may be able to define the exposure. And then if you have this hazard in a scenario, you can determine the severity. So here we show how that is combined with the TNO StreetWise approach. For each of the triggers that may lead to a hazardous event in the SOTIF approach, you can define the risk if you combine it with a scenario. So the same trigger and the same event at night on a highway might have a different effect than when it's in a scenario in an urban rush hour. So analyzing all these hazards, you can calculate the risk by using the probabilities, the exposures from driving data, see whether this event is happening under the condition of a certain scenario, parameterize that event and scenario, and run it in simulation and define the severity of that. So combining exposure and severity, we have the risk and can aggregate for the full function under test. Good. So then we come to the point of comparing data sets. First of all, you can do this because you want to know, are we state of the art with what we collected so far? So a simple measure is to see and look at the scenario coverage, and if that is sufficient, then that's a first stage. But a more correct or more detailed view is on the parameterization, and to see how this develops on as you collect more data or combine more data sets. So that means you can also use this kind of curves to compare to others, to other data sets, and to also have a measure whether a certain data set can be at some point be declared a reference data set. So if we combine all this, we do this with partners naturally, and we see quite some activities going on. The process is to detect scenarios and do the calculations as local as possible. Meaning that if we have roadside detection, we try to do the scenario detection and parameterization at that location or in that business context, and only share the results to a trusted third party like TNO. The same with vehicle owners. You want to process and detect your scenarios locally at the company, do the parameterization locally, and only share the outcomes, not the driving data. So this means that combining from various sources, you can add also external information like maps, for example, and enrich the scenarios. You can build up the scenarios across data sets and compare them, and you can use this for synthesizing edge cases, like the sort of approach that I showed. In the end, at the level of the group of scenario database users, this leads to a shared scenario database, which quickly grows from the different sources, and also a means to compare data sets and to have a measure of the completeness. Conclusion. Have we collected enough traffic data? Well, we can tell if we look at the parameterization and how that develops over time. And we can look at the scenario coverage as a simple measure, but really the parameterization is what we want to look at. And this gives us a means to compare with other data sets and define a reference data set. We demonstrated this in a PUMAS project with 4 parties, and currently we're expanding this group of scenario database participants. And the statistics also help you to quickly identify where is my data collection not good enough yet, where do we need to collect additional data. So I want to thank you, and I want to thank the Head Start project and the EU for supporting this, and I'd be happy to answer any questions.